Hey everyone, we are Team 8 SAO. Today we will present our project Automatic Speech Verification Spoofing Detection. Before we get started, let's listen to 3 audio clips can distinguish which one is real or not.
Take a look at these pages for Crooked Creek. Take a look at these pages for Crooked Creek Drive.
Take a look at these pages for Crooked Creek Drive.
Actually, all of these 3 audios are fake. Automatic speech verification spoofing is to distinguish whether the given audio is real or fake. Currently, deepfake can not only generate fake human face but also human voice, which poses a severe threat on the trust of social media. The most challenging aspect of this task is that the fake audio samples become harder to identify, considering that the development of new speech generation and voice conversion techniques nowadays. Related work can be divided into 2 parts. The first one is neural network based, such as VAE or BLSTM. The second one is machine learning based. Although neural network based methods have been popular nowadays, classical methods such as SVM and GMM are still play an important role in this field. Our project focuses especially on non-neural network methods. In our projects, we have 3 steps. First, we re-implement CQCC features in Python. As far as we know, there is no such code on public now. Then, we implement 2 machine learning methods, SVM and GMM, as our classifier. We use the logic access dataset in ASV spoofing computation. This dataset contains more than 20,000 training samples and 70,000 testing samples. There are 46 male and 61 female speakers in our dataset. Here is the pipeline of methods. Feature extraction and classifier are the 2 main parts of our work. We follow the setting as previous work and using MCC and CQCC as features in our task. We will not go details, but these features have proved to be effective to distinguish fake audio. We use MFCC from LibreOsa library and our own implemented CQCC. Note that audio samples have variable lengths, so we pick the first 50 frames of the MFCC and CQCC features and flatten them as inputs. In the model part, we implement 2 kinds of classifier, GMM and SVM, using the sklearn library. SVM have proved success in many machine learning tasks. The SVM classifier aims to maximize the margin boundary of samples. It is therefore more robust and generalizable. Kernels such as RBF can also be utilized for efficient feature transformation. The Gaussian mixed model can be regarded as a model composed of k-single Gaussian models. In our work, the classifier consists of 2 GMM models that were trained from bona and spoofed audio samples separately. We utilize the MFCC features extracted from each sample, calculate and concatenate the data of MFCC, and stack them together as inputs. We evaluate our method on 2 common metrics, classification accuracy and EER. EER is the equal error rate, which is the point where false identification and false rejection rate are minimal and optimal. The lower EER, the better the system. Although the performance of machine learning methods are lower than N-based methods, machine learning methods achieve low EER given good features such as CQCC and MFCC. In our experiments, the performance of CQCC is lower than our expectation, as it is usually thought as a power feature for spoof detection. One of the reasons is that our Python implementation is kind of different or have some small bugs. That is our representation. Thank you so much.